Hold on, I'm still confused on why we can't have black LED lights.
I was tagged in this video, so let's break down the science behind it. We have red lights, blue lights, green lights, every color you can imagine. So why can't you flip a switch and make a room glow black? Why is there no such thing as a black colored light? The answer is actually very simple, but it reveals something fundamental about how light itself works. First, we need to understand what color actually means. Color is not a property of objects. Color is how our eyes interpret different wavelengths of light. Light is electromagnetic radiation, energy traveling as waves. Different wavelengths correspond to different colors. Short wavelengths look blue or violet, medium wavelengths look green, long wavelengths look red. When a light source emits a certain wavelength, your eyes detect it, and your brain translates that signal into color. So when you turn on a red light, the bulb is literally emitting red wavelengths. Color equals light being added to your eyes. Now, here's the key idea. Black is not a color of light. Black is the absence of light. When no visible light reaches your eyes, your brain perceives black. That means you cannot create black by shining something. You can only create black by removing light. It's like silence in music. You can play louder sounds or different notes, but silence isn't another sound you can broadcast. Silence happens when sound stops. Black works the same way. Light adds color, darkness removes it. Now you might be thinking, wait, what about black lights? Those purple-looking lights used at parties or science labs? Here's the twist. A black light isn't black at all. It actually emits ultraviolet light, or UV light, which sits just beyond violet on the electromagnetic spectrum. UV light is mostly invisible to human eyes, but it carries energy that makes certain materials glow, a process called fluorescence. Those glowing whites and neon colors you see under a black light aren't the light itself. They're objects absorbing invisible UV energy and re-emitting visible light. So even something called a black light is still adding light, just outside the range we normally see. Imagine trying to build a lamp that shines darkness. The problem is physical. Light sources emit photons, tiny packets of energy. To create black light, in the literal sense, you need a device that emits negative photons, removing light from everywhere it touches. And that doesn't pair well with physics. You can block light, you can absorb light, you can even reduce brightness. But you cannot project darkness outward like a beam. The closest thing we have is materials that absorb almost all incoming light, like ultrablack coatings used in astronomy. But even those don't emit blackness. They just prevent reflection. They don't shine dark. They simply refuse to shine. This question feels simple, but it highlights something important. Our brains treat black and white as colors, but physically they behave differently. White light is all visible wavelengths combined. Black is none of them. So every light you've ever turned on adds energy to the world. Darkness only appears when energy is missing, which means a room glowing black would require breaking one of the most basic rules of physics. Energy can be emitted, but absence cannot. So why don't we have black-colored light? Because light creates color, and black isn't something light can create. Black is what you see when light stops arriving. Even the so-called black light is just invisible ultraviolet energy making other things glow. In the universe, brightness can be produced. Darkness can only be revealed.